Hello, this video is on solving systems of equations using substitution. So a couple steps that might help you solve. Step 1 says solve for one variable in one of the equations if necessary. Sometimes step 1 is already done for you. Step 2 says substitute the resulting expression into the other equation. Step 3 says solve that equation to get the value of the first variable. So after step 3 you should have solved for x or y, so you should know what it is. Step 4 says substitute that value into one of your original equations and then solve. So after step 4 you should have both your x and your y. So step 5 is just to write the values from step 3 and 4 as an ordered pair and check. So we're going to go through some examples. The first one says y equals 2x and y equals x plus 5. Well, our first step says that we need to make sure one of our variables are solved for. Well, in this case, in both equations, both of the y's are already solved for, so our step 1 is done. So we can then go on to our next step. So we're going to take what y is equal to. So if we look in the top equation, we see that y is equal to 2x. So I'm going to take that, what y is equal to, which is 2x, and I'm going to substitute it in for my y here. So my resulting equation is going to say 2x is equal to x plus 5. So now if you'll notice, the only variable I have in this equation is x. That's good. Now I can solve for x to figure out what it is. So from here we just solve like we normally would. So I'm going to subtract x. I get x is equal to 5. Awesome. I have one variable solved for. Now I need to solve for my second one, which is y. To solve for y, I can go back to either my original equations, so I could use y equals 2x or y equals x plus 5. It doesn't matter. I'm going to go with the first one, y is equal to 2x. So y is equal to 2 times 5. Y is equal to 10. For our last step, we're going to write it as an ordered pair. So our solution to the system of equations, the point where those two lines cross, is 5, 10. Alright, let's look at another example. Again, we want to see first if in one of our equations if x or y is solved for. Well, in this second one here, we can see that y is by itself. So my first step is done. So I'm going to take what y is equal to. Y is equal to x minus 4. And I'm going to take it and put it into my other equation for y, since that's what it's equal to. So now my resulting equation is going to say 2x plus, and now instead of y, I'm going to put x minus 4 is equal to 5. Now I only have one variable, just x again, which is good, which means I can solve for x. So I'm going to combine like terms first to get 3x minus 4 is equal to 5. I'm going to go through my normal steps of solving for x now, so I'm going to add 4 to both sides. I get 3x is equal to 9, divide by 3, and x is equal to 3. Now I can put x back into either of my two equations up here. I'm going to use the bottom one. It's going to make it easier to solve for y. So I can see y is equal to x minus 4. So y is equal to 3 minus 4. So y is equal to negative 1. My last step is to write it as an ordered pair. So 3, negative 1. Alright, if we look at these two equations, we have x plus 4y is equal to 6 and x plus y is equal to 3. We don't have a variable that's by itself yet because x and y are on the same side in those equations. So we need to get something by itself. Doesn't matter which one. I'm going to go with the bottom equation. And this time, I'm going to go ahead and I'm going to get x all by itself. So I'm going to subtract y. So then x is equal to 3 minus y. Okay? So now I know x is equal to 3 minus y. I need to take what x is equal to, all of this. And now because it's what x is equal to, I need to put it in for x. So I'm going to put it in for x there. So now I have 3 minus y plus 4y is equal to 6. Combine like terms, I have 3 plus 3y is equal to 6, subtract 3. So I have 3y is equal to 3, divide by 3. I can see y is equal to 1. So now I have y solved for, which is great. Notice I solved for y here first. In my other examples I solved for x. It doesn't matter which one you solve for first. We just have to solve for both of them by the time we're done. So now I'm actually going to use this equation right here to solve for x because it's the easiest one. It's the fastest one. So I'm going to do x is equal to 3 minus y. So x is equal to 3 minus 1. X must be equal to 2. So my ordered pair would be 2, 1. If I wanted to be checking these, I would plug x and y back in to see if it worked, or I could maybe graph these if I wanted to verify it that way also. Alright, in this one we have 4y minus 5x equals 9, and x minus 4y is equal to 11. Again, x and y, neither of them are solved for, so I have to pick something to get by itself. I could get x by itself in the top equation, I could get y by itself, same with the bottom equation. I'm actually going to get this x by itself, and the reason I chose that one is because the coefficient in front of it, or the number in front of it, is 1, so it's going to be the easiest one to isolate. So, I have to add 4y, and if you guys picked to isolate a different variable, you still get the right answer. So it should be 11 plus 4y, oops, that y kind of looks like an x. Okay, and now that's what x is equal to, so I'm going to take everything x is equal to, stick it in for my x up there. Now I'm going to rewrite that top equation. So I have 4y minus 5. That 5's in front of the x, so I need to put everything x is equal to in parentheses. So 11 plus 4y is equal to 9. Now at this point I'm going to have to distribute this 5 through. So I have 4y minus 55 plus 20y, or excuse me, that should be a minus 20y. Minus 20y is equal to 9. Combine like terms, so I get negative 55 minus 16y is equal to 9. Add 55 to both sides. And I get negative 16y is equal to 64. Divide out my negative 16. And I get y is equal to negative 4. Now again, I have to go back and solve for x. To solve for x, I could use my top equation, my original top equation. I could use the second equation I was given, or I could use the one where I solved for x. I'm going to use this one again because it's fastest for me. So I have x is equal to 11 plus 4y, or x is equal to 11 plus 4 times negative 4. X is equal to 11, and that's going to turn into a minus 16, so x is equal to negative 5. My solution to the system of equations is negative 5, negative 4. And again, we're going to do a word problem because you'll have some of these in your homework. So it says one high-speed internet provider has a $50 setup fee and costs $30 per month. Another provider has no setup fee and costs $40 per month. In how many months will both providers cost the same? So in this case, we only have to have one answer. It's not going to be an ordered pair because they're only asking about the number of months. So my first option has a $50 setup fee and costs $30 a month. So that $50 is a one-time fee plus $30 every month, so 30x. My second one has no setup fee, so that's $0, but it's $40 per month. So I'm just going to say 40x. And we have to figure out in how many months you'll have spent the same amount of money on them. So my y's are already solved for, so I'm going to take what y is equal to, which is 40x, and put it in for that y. So I get 40x is equal to 50 plus 30x, and I'm going to go ahead and solve for my x's. Leaves me with 10x is equal to 50, and divide out my 10. So x is equal to 5. Now I have to ask myself, what does x represent? Well, if I look at x in my formula, so I have 30 times x and 40 times x, that's my monthly cost. So x month must be my months. So I don't need to solve for y here because it's only asking for months. So after 5 months. If it wanted to know the cost after 5 months, I would plug that back in to get it. Thanks for watching!